In the 1970s, the future of the ocean looks less like a boat and more like an airplane. For a brief moment in time, we stopped trying to push through the waves and started flying over them. These were hydrofoils, vessels that could travel faster than a traditional high-speed ferry, offering a smooth, futuristic ride that promised to revolutionize coastal travel.
Aerospace giants and world-class navies poured billions into this technology.
They were faster, more efficient at high speeds, and looked like something straight out of a science fiction movie. Yet, if you look at our harbors today, these flying boats have almost entirely vanished. Most people today have never even seen one in person, let alone stepped on board. Why did a technology backed by some of the greatest engineering minds on Earth essentially disappear? You might think the answer is just high fuel prices, but that is only a small part of the mystery. There was a nearly invisible weakness lurking beneath the surface that mattered even more. To understand why they left, we have to understand how they worked. Think of a conventional boat. As it moves, it has to shove a massive amount of water out of its way. This creates immense drag. A hydrofoil changes the game by using underwater wings, or foils. As the boat picks up speed, these wings generate lift, exactly like the wings on an airplane. Once the boat hits a certain velocity, the entire hull rises out of the water. At this point, the only parts of the vessel touching the sea are the small, thin foils. Less surface area means less friction, which translates into incredible speeds that no standard hull could ever hope to achieve. On paper, hydrofoil technology solved one of the oldest problems in maritime engineering, but lifting that hull out of the water created several new problems directly underneath it. The mid-20th century was an era of unbridled optimism for this technology.
Governments across the globe saw hydrofoils as the ultimate solution for rapid coastal transportation. Navies were equally excited, envisioning fast patrol vessels that could outrun any submarine.
This was not just an eccentric experiment by small-time boat builders. The Boeing Company, famous for its iconic jetliners, transferred its aerospace expertise into the water with the Model 929 jetfoil program. This was a serious piece of maritime engineering that utilized computer-stabilized foils and water jet propulsion. Major routes began popping up in Hong Kong, Japan, across the English Channel, and throughout the Mediterranean.
When you look at the promotional materials from that era, you see passengers sitting in cabin environments that looked exactly like a Boeing 747. It felt like the dawn of a new age where the distinction between sea travel and air travel was finally blurring. For a while, hype was justified. Both passengers and operators loved these machines. Hydrofoils can cut travel time in half between islands or busy waterways. Smaller waves that would cause a ferry pitch and roll did not harm the boat because its hull was above water.
The passengers felt less seasick and had a smoother journey. Being able to compete with road or short-haul air transport was gold for operators. Hydrofoils were marketed to time and comfort-conscious customers. The hydrofoil seemed poised to rule every major coastal city. When the boat slowed down, reached a congested harbor, or hit anything underwater, its greatest advantage became its worst disadvantage. The initial challenge was that a hydrofoil is two boats in one. The vessel must function in two distinct modes to succeed. It sits hull-borne in the water, like a ship at the dock, or slowly going through a harbor. The enormous foils and support struts underneath are dead weight and drag in this state. The boat must work hard to reach takeoff speed where the foils can lift. This is the drag hump. Pushing through this inefficient stage takes massive power. Hydrofoils were great for the fastest section of the route, but cumbersome and inefficient elsewhere. Flight needed exact balance and weight distribution, so adding cargo or changing passenger load may severely affect performance. This leads to the second issue. Speed got very expensive. The transition from technical ambitions to economic reality hurt many operators. Hydrofoils are efficient once on their foils, but getting there and remaining there requires large, high-maintenance motors. These marine diesels are often aeroplane turbine derived. Operators faced massive fuel usage at high speeds, then maintenance. Saltwater severely stresses and corrodes foils. Marine growth like barnacles can destroy foil lifts, requiring frequent, expensive cleanings. A local shipyard couldn't replace a broken specialized part. Needed aeronautical technicians. Maths eventually stopped adding up. Hydrofoils sold speed, whereas traditional ferries sold seats. In shipping, more seats imply more money. The physical risk beyond the financial sheets was practically unforeseeable. The ocean is full of invisible impediments. The foil system is sensitive to submerged debris because it is deep underwater. Floating logs, fishing gear, and huge plastic debris can entangle or hit foils, causing catastrophic failure. The structural impact of hitting a submerged log at 40 knots is significant. A damaged foil can dump the boat back into the sea fast, disrupting operations and causing huge repair expenditures. Modern foil design still prioritizes trash. It meant a single piece of floating trash might take a multi-million-dollar vessel out of operation for weeks. Even with pure water, the ecosystem fought back. Engineers faced waves, wind, and cavitation. The hull stays above modest waves, but strong or irregular seas can affect the foil's lift. While the boat is in flight, big waves hitting the bottom of the hull are powerful and painful. Wind is another issue. Lifted boats have a high center of gravity and a lot of surface area for the wind to grab, making stability a constant battle for flight control computers. The most invisible adversary was cavitation. At high speeds, the foil's back pressure decreases so low that water boils, generating vapor bubbles. Bubble collapses emit shock waves that can chip foil metal. It created vibrations and reduced lift, slowing these vessels. Hydrofoils struggled, but the high-speed catamaran quietly won the race. Shipbuilders realized that going quickly didn't require lifting the boat out of the water. Catamarans cut through water with low drag because to their two thin, streamlined hulls. These watercraft were easier to build and maintain than hydrofoils. Their vast decks could transport hundreds of cars and thousands of passengers, unlike weight-sensitive hydrofoils. They could function in shallower water and didn't need computer-controlled wings to stand. Catamarans didn't need to defeat hydrofoils at their finest. It merely needed to be fast enough and cheap for the other 95% of its life. The industry didn't collapse immediately. It shrank route by route. The initial Boeing jetfoils and their competitors aged, making maintenance difficult. Operators didn't replace hydrofoils when a route became too expensive or a vessel needed a substantial refurbishment. They bought catamarans. The time advantage that made the hydrofoil worth the extra expense was sometimes eliminated by stronger environmental restrictions and speed zones around harbors. Hydrofoils didn't die since they weren't machines. They disappeared because they only worked under certain profitable conditions. By 2000, they were limited to a few areas, notably the high-speed Hong Kong-Macau line, where speed justified the price. There is a twist to this story. It is possible that hydrofoils will undergo yet another takeoff. Since the 1970s, this world has undergone an evolution. At this point in time, we have carbon fiber composites that are lightweight, electric motors that have a high torque, and sensors that are thousands of times more sensitive than those that Boeing had in the 1970s. The hydrofoil is being brought back to life for use in electric boats by modern maritime engineering. Because electric batteries are cumbersome and have a limited amount of energy, the only way to get a respectable range at high speeds is to reduce the amount of drag that they experience. 2024 marked the beginning of service for the electric hydrofoil ferry known as the Stockholm Candela P12. It was reported that the voyage time was reduced from 45 minutes to 30 minutes, yet at the same time it consumed a quarter of the energy that a conventional boat would. Waves are eliminated by the precision computer-controlled foils that are installed on these modern vessels, which makes flying a tranquil and sustainable activity. Finally, the verdict? Hydrofoil dreams were dashed by high operating costs, complicated maintenance, and underwater wings vulnerability. A victim of its own sophistication, high-capacity catamarans took over because they were more profitable. But the hydrofoil's underlying physics, that flying over water is better than pushing through it, was never wrong. The hydrofoil was fine.
It arrived before the motors, materials, and computers needed to make it mass marketable.
With the push for green energy and digital stabilization, the boat that disappeared may eventually surface. Flying boats are entering their second age.